Hello students, today we will discuss about class 10th chapter 12. In the previous video we have discussed about electric current, charge, potential difference and Ohm's law. Today we will discuss about the circuit symbols of a circuit diagram. Okay, so first is electric cell. Electric cell is represented by this symbol. This is the positive terminal of a battery and this is the negative terminal of a battery. Then if we will connect a number of cells in series, then the symbol will be like this. Means one's positive plate is connected to another's negative plate. Okay. Then plug key, or we can say switch. If switch is opened, then this is represented by this symbol without the dot. And plug key, if closed or switch is closed, then this is represented by this symbol. Okay. Then if we joint some wires, if a wire is joined, then there will be a junction. Okay. This point is called junction. And it is represented by this symbol. This is a wire, this is another wire, and this is another wire. These three wires were joined here. Okay. Next, wires crossing without joining. If wire crossing without any joint, then this is represented by this symbol. Okay. Then electric bulb is represented by this symbol. And resistor is represented by this one. Okay. Rheostat is represented by this symbol or this type of symbol. Okay. Then if we want to represent emitter in a circuit, then this is represented by this symbol. Means this is the positive terminal, this is the negative terminal, and here ammeter is connected. And in the previous class we have discussed ammeter is connected in series with the main circuit. Okay. Then if we will represent voltmeter in this symbol, this is the positive terminal of voltmeter, this is the negative terminal of voltmeter, and voltmeter is connected in this circuit. And in previous class we have discussed voltmeter is connected in parallel with the main circuit. Now we will discuss about factors on which resistance of a conductor depends. Okay. The first factor is, it is observed that ammeter reading decreases to 1/2 when the length of wire is doubled. If we double a length of wire, then ammeter reading decreases. Why? The charge has to travel a long distance, then resistance depends on length. So resistance also increases, so current decreases in that case. That's why the ammeter reading also decreases when we double the wire. Okay. The ammeter reading is increased when a thicker wire of the same length is used in the circuit. If we use a thicker wire, means area of cross section is greater, but the same length of wire what is used in first one. Okay. Then the flow of electron will be very easy. That's why current in the ammeter is more. Okay. Then a change of ammeter reading is observed when wire of different material of the same length and same area of cross section is used. If we hold the area and the length same proportion of different wire or different material of wire, then the current or the ammeter reading also changes, because different material have different type of resistivity. That's why the ammeter reading also changes for different material of wires. Next one is, we can conclude that resistance of a conductor depends on its length. Obviously if we increase the length, then resistance increases. Area of cross section, it depends on area in the second point. And the nature of the material. Okay. So resistance depends on length, area of cross section and the nature of the material. Okay, so we can conclude that resistance of a uniform metallic wire is, first point is directly proportional to length, because if we increase the length then resistance also increases. So directly proportional to length. Okay, so if resistance will be R, then it will be directly proportional to length of the wire, that is L. And secondly, it is means resistance is inversely proportional to area of cross section of wire. Means if we increase the area then resistance decreases. So resistance is inversely proportional to area. Let us say resistance of a wire is R and it is inversely proportional to area A. So if this will be equation 1 and this will be equation 2, if we will combine these two equations, what we will get? R is proportional to length upon area. Okay, resistance is proportional to length upon area. So if we want to remove this proportionality, then we have to multiply a proportionality constant. So R is equal to rho L upon A, where this symbol is called rho, R-H-O. Okay, and this is a proportionality constant. And rho is the resistivity of a material. So resistivity of a material is different for different materials, but for a same material resistivity is equal. Okay, any length or any cross section, resistivity is constant for a material of same composition. So what will be the SI unit of resistivity? SI unit of resistivity is ohm meter. Previous class we have discussed the SI unit of resistance is ohm. So resistivity SI unit is ohm meter. Okay. Then metals and alloys have very low resistivity in the range 10 to the power minus 8 to 10 to the power minus 6 ohm meter. Means the resistivity of materials like conductors, or we can say metals and alloys, have low resistivity. So for insulators like rubber and glass, the resistivity is very high, that is in the order of 10 to the power 12 to 10 to the power 17 ohm meter. Then both resistance and resistivity of a material varies with temperature. Resistance and resistivity will vary with temperature. Then there will be a table appearing on your screen. Just look at the table. There are some conductor, alloys and insulator and materials, and we will discuss their resistivity in ohm meter. The SI unit of resistivity, ohm meter. Okay. So in the conductor section we have silver. Silver has a resistivity of 1.60 into 10 to the power minus 8 ohm meter. Copper has a resistivity of 1.62 into 10 to the power minus 8 ohm meter, and aluminium has a resistivity of 2.63 into 10 to the power minus 8 ohm meter. Then tungsten has a resistivity of 5.20 into 10 to the power minus 8 ohm meter. And nickel has a resistivity of 6.84 into 10 to the power minus 8 ohm meter. Iron has a resistivity of 10 into 10 to the power minus 8 ohm meter, and we can write it 1 into 10 to the power minus 7. Then chromium has a resistivity of 12.9 into 10 to the power minus 8 ohm meter. Mercury has a resistivity of 94 into 10 to the power minus 8 ohm meter, and manganese has a resistivity of 1.84 into 10 to the power minus 6 ohm meter. Then we'll come to the section of alloys. Constantan is an alloy combination of copper and nickel, has a resistivity of 49 into 10 to the power minus 6 ohm meter. Then comes manganene. It is an alloy of combination copper, manganese and nickel, has a resistivity of 44 into 10 to the power minus 6 ohm meter. Then comes nichrome. Nichrome is a combination of nickel, chromium, manganese and iron, has a resistivity of 100 into 10 to the power minus 6 ohm meter. So we come to the section of insulators. Insulators like glass has a resistivity of 10 to the power 10 to 10 to the power 14 ohm meter. Hard rubber has a resistivity of 10 to the power 13 to 10 to the power 16 ohm meter. Ebonite has a resistivity of 10 to the power 15 to 10 to the power 17 ohm meter. Diamond has a resistivity of 10 to the power 12 to 10 to the power 13 ohm meter, and dry paper has a resistivity of 10 to the power 12 ohm meter. So in this table we have discussed about conductors, insulators and alloys. So all the resistivity has given in the table. Now we will discuss a question. The potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? Means the circuit is same. We are changing the potential difference. Okay. Let us say first we will write what is given. First voltage is given, means let us say V1 is equal to 60 volt. Okay. Then current has given, I equal to 4 ampere. Okay. First we have to calculate the resistance using Ohm's law. Using Ohm's law, what is Ohm's law? Ohm's law is V equal to I into R. Okay. From this relation we can find out resistance. Okay. So R is equal to V by I. Okay. So if we will put the values, then resistance of the circuit will be R equal to 60 volt divided by 4 ampere. Okay. So if we will cut this, then this will be 15 ohm. The unit of resistance is ohm. So we have calculated the resistance of the circuit. So our new voltage is 120 volt. So V2 is equal to 120 volt. What we have to calculate? Current. Okay. So from this relation, what will be the current? Current I is equal to V by R. Okay. V by R. So from this relation, current I will be, what is the potential difference? 120 volt divided by, what is the resistance? 15 ohm. We have calculated this one. So what will be the current? Current is, so this will be 15 8 ja, means 8 ampere. So when we'll connect the heater to the new voltage of 120 volt, the current drawn will be 8 ampere. You will practice some questions from this section from your exercise book, and if you have some doubt, then comment in the comment section. Thank you.